Good day everyone, I am Franz-Special and I will be your teacher for today. And together we are going to tackle about the topic special products. And we are also going to unravel why these products are called special. There are 4 kinds of special products. So let's start with the first special products. It is the product of the sum and difference of 2 binomials, whose definition is read as the square of the difference or its squares of their difference. So if you are going to encounter a product of a sum and difference of binomials, for example, the quantity of f plus L, where f stands for the first term and L stands for the last term, multiplied to quantity f minus L. It's just simply equal to the square of the first term subtracted to the square of the last term. Let's try to evaluate the following examples. Example number 1, we have quantity x plus 2 multiplied to quantity x minus 2. Remember that in a product of a sum and difference, that we are just going to simply square its first term subtracted to its square of the last term. So we have x plus 2 multiplied to quantity x minus 2. So its answer is just simply equal to the square of the first term, which is x. So we have x squared subtracted to the square of the last term, which is 2. So the square of our last term is 4. So our final answer is x squared minus 4. And our second example is quantity 2x raised to the power of 4y plus 6 multiplied to quantity 2x raised to the power of 4y minus 6. And again, in order to solve this, just simply square the first term subtracted to the square of its last term. So it is equal to 4x raised to the power of 8 y squared minus 36. So our final answer of this example is 4x raised to the power of 8 y squared minus 36. And to our second type of special product, we have the square of a binomial, whose definition is just simply given the square of a binomial, in order to find its solution or its answer, just simply square the first term plus twice the first term and the last term plus square of the last term. And it also has its square of a binomial whose sign is negative. As you can see, it only differs on its negative sign. Given a square of a binomial whose sign is negative, the negative sign is just located on the second term of the product. So let's have an illustrative example. Given, so our given number 1, we have quantity x plus 4 squared, or it can also be read as quantity of x plus 4 raised to the power of 2. So let's try to answer the number 1. So again, you need to familiarize our formula or the definition or given a square of a binomial. Just substitute the following formula. So in given number 1, we have x plus 4 quantity squared. So in this given, we're going to use formula number 1. Just simply square the first term. So our first term in the given is x. So the square of the first term is x squared. Plus twice the product of the first term, which is x, and the last term, which is 4. Plus the square of the last term, which is 4. And now let's simplify our expression. X squared, just simply copy. 2 times x, 2x, times 4, 8x. Lastly, 4 raised to the power of 2 or 4 squared is 16 plus 16. So our final answer in the expression number 1 or our example number 1 is x squared plus 8x plus 16. And to our third special product, we have the square of a trinomial. Here in the square of a trinomial, we have 4 formulas. So as a definition, given a square of a trinomial, it's just simply equal to square of the first term plus square of the middle term plus square of the last term plus twice the first term and the middle term plus twice the middle term and the last term, and lastly plus twice the first term and the last term. So it is just a very simple to remember. Just simply square all the terms from first term to the middle term and to its last term. Just square it first. Plus twice its first term multiplied to its middle term plus twice its middle term multiplied to its last term and plus twice to its first term multiplied to the last term. As you can see, we have 4 formulas in this kind of trinomial. So I want you to familiarize that with these 4 formulas, I'll be giving you cues where to put the negative sign whenever you're going to encounter this kind of trinomial whose negative sign, whose last term is negative on the given, and on the third formula whose the middle term is negative, and lastly on the fourth formula whose middle term and last term is negative. So with this one, the negative signs are located in the 5th term and the 6th term of the product. And in the third formula, if you're going to encounter a trinomial whose the middle term is negative while its last term is positive, the negative signs are located on the 4th term and on the 5th term. And in the 4th formula, whenever you encounter a kind of trinomial, a square of a trinomial, whose the middle term and last term are negatives, the negative signs on the product is located on the 4th term and on the 6th term. So with that, it will give you a clue where to place the negative signs whenever you encounter these 3 kinds of trinomials. So let's try to evaluate these examples. We have here 4 illustrative examples. So let's try the first example. So we have example number 1. The given is quantity x plus 3y plus 2z. Quantity squared. So given this expression, we are going to use the first formula of the square of a trinomial, which is simply, the first one is square all the terms. The first term, the middle term, and the last term. We have x squared plus three y squared plus 2z squared. And the next one is, don't forget our formula, added to twice the first term and the middle term. I mean twice the multiplication of middle term and its first term. We have x multiplied to 3y plus twice the middle term and the last term. Our middle term here is 3y and our last term is 2z. Or it can be interchanged, as long as it is the multiplication of the middle term and the last term. And lastly, plus twice the middle term and the last term. Now we have the expression. So let's try to simplify this expression. Copy the first term, x squared plus square of 3y, or 3y quantity squared, we have 9y squared plus quantity 2z squared is 4z squared plus 2 times x, 2x times 3y, 6xy. Plus 2 times 2z, or 2 multiplied to 2z and multiplied to 3y, we have 4z multiplied to 3y, it's 12zy, or 12yz. Plus 2 multiplied to x, we have 2x, and multiplied to 2z, we have 4xz. And now we have our conclusion, or the simplified expression. Quantity x squared plus 9y squared plus 4z squared plus 6xy plus 12yz plus 4xz. And that is our final answer of example number 1. Now let's proceed to our second example. We have minus 3 quantity squared. So, since this is the given trinomial, as you can see, the pattern, we have a positive middle term and a negative last term. So the formula that we are going to use is that the product or the negative signs in the product are located in the 5th and 6th term. So let us evaluate. X is our first term, Y as our middle term, and 3 as our last term. Regardless of its sign, let us substitute the following to the formula. First is square the first term plus square the middle term plus square the last term plus twice the product of the first term and the middle term. So our first term here is x, and our middle term is y, plus twice the product of the middle term and the last term. And since it is negative here, it is not positive here. So it is minus twice the product of the middle term, which is y, multiplied to the last term, minus twice the product of the first term, which is x, and the last term, which is 3. Let us simplify the given expression. Copy x squared and y squared. So 3 squared is 9. Plus 2 times x times y, we have 2xy. Minus 2 times y, 2y. Times 3, 6y. Minus 2 times x times 3 is 6x. So now, we have our final answer of the expression quantity x plus y minus 3 squared is just equal to squared plus y squared plus 9 plus 2xy minus 6y minus x. And that is our final answer. Now let's proceed to our third illustrative example. As a given, we have quantity 2m minus 3n plus 4 quantity squared. As you can see, the negative sign is located on the middle term. And as the pattern or the formula, the negative sign is located on the fourth term and the fifth term. So let's evaluate. 2m minus 3n plus 4 quantity squared. So it is equal to, again, the first step or first is square all the terms. Square the first term added to the square of the middle term added to the square of the last term. We have 2m squared plus 3n squared plus 4 squared plus, minus, since the negative is on the middle term, minus twice the product of the first term and the middle term we have 2m times 3n minus twice the product of the middle term and the last term. 2 3n multiplied with 4. And lastly, plus twice the product of the first term and the last term. 2m multiplied to 4. Now let's try to simplify the expression. Now, this expression is now equal to 2m squared, or quantity 2m raised to the power of 2. We have 4m squared plus 3n squared is 9n squared plus 4 squared, which is 16, minus 2m times 3n is equal to 6mn multiplied to 2, 12mn. Minus 3n times 4 is equal to 12n multiplied to 2, we have 24n. And lastly, 2m times 4 is 8m multiplied to 2 is equal to 16m. As you can see, we already have our final answer. Now let's proceed to our fourth example. In the given, we have quantity 3x squared minus 2y squared minus 1. Quantity squared. As you can see, in our formula, the pattern of given a square of a trinomial whose sign of the middle term is negative and whose sign of the last term is negative is we are going to substitute the formula where in the product, the negative is located on the fourth term and in the sixth term of the product. So let's proceed. So in our formula, first we're going to square all the terms, starting with the first term, the middle term, and the last term. Square of the first term where 3x squared, quantity squared, plus square of the middle term, 2y squared, quantity squared, plus square of the last term, which is 1 squared, minus twice the product of the first term, which is 3x squared, multiplied to the middle term, which is 2y squared, plus the product, twice the product of the middle term and the last term. We have 2 multiplied to our middle term, which is 2y squared, multiplied to its last term, which is 1, minus twice the product of the first term and the last term. Our first term again is 3x squared, multiplied to our last term, which is 1. So let us let's simplify the given expression. Now we have 3x squared, quantity squared, is equal to 9 it is just the law of exponent where given an exponent, power to a power, where 2 is raised to the power 2, just simply multiply the exponent, where 2 times 2 is equal to 4. X raised to the power 4 plus, apply the law of exponent, which is law of the exponent, a power to a power, we have 2 squared is 4, y raised to the power of 4 plus 1 squared, which is 1, minus 3x squared multiplied to 2y squared is 6x squared y squared times 2, it's equal to 12x squared y squared plus 2 times 2y squared is 4y squared multiplied to 1, 4y squared. And lastly, minus 2 times 3x squared times 1 is equal to 6x squared. And now we have our final answer of the given quantity 3x squared minus 2y squared minus 1 quantity squared is equal to 9x raised to the power of 4 plus 4y raised to the power of 4 plus 1 minus 12x squared y squared plus 4y squared minus 6x squared. And now we have our final answer. Moving on to our fourth type of special product, we have the cube of a binomial. And with its definition, it is read as, given a cube of a binomial, it is just simply equal to cube of the first term plus thrice the product of the square of the first term and the last term plus thrice the product of the first term and the square of the last term plus plus the cube of the last term. And as you can see, we have two formulas here. The two formulas will determine of the given. For an example, you have a cube of a binomial whose sign is positive, then you are going to follow the positive sign formula. And whenever it is negative, the negative sign is located on the second term of its product. Now let's try to evaluate the illustrative examples. So in our given number 1, quantity 2a plus 3, quantity cube. Now let's try to situate and evaluate this expression. First thing to do is cube the first term. And our first term here is 2a. The cube of 2a plus thrice the product of the square of the first term and multiply to its second term or last term, which is 3, plus thrice the product of the first term, which is 2a, multiplied to the square of the last term, plus the cube of the last term, which is 3. Now let us simplify the given expression. 2a raised to the power of 3 is equal to a, because 2 raised to the power of 3, or 2 cubed, is equal to 8. And a cubed plus 3 multiplied to 2a squared multiplied to 3 is equal to 3 times 3 is equal to 9. 9 times 4 is equal to 36. So our second term will be 36a squared. Plus 3 times 2 is equal to 6. And 3 raised to the power of 2 or 3 squared is 9. So 9 times 6 is equal to 54 and copy A. So we have 54A. And lastly, 3 raised to the power of 3 or 3 cubed is equal to 27. Now we have our final answer. So quantity 2a plus 3 quantity cubed is equal to a cubed plus 36a squared plus 54a plus 27. For example number 2, I want you to try this on your paper. So this will serve as your practice exercise. And that would be all for special products. I hope you've learned something from my discussion. For more practice exercises to answer, please click the link below. And don't forget to subscribe our channel. Thank you for watching.